Class 209, let us see a video on MEMS.
Look closely and you will see them. Tiny machines, nearly invisible to the human eye. These micro machines make automobiles safer, insulin pumps for diabetics more accurate, and hearing aids more efficient. MEMS, or micro-electro-mechanical systems, describes both a category of devices and the technique for manufacturing them. These tiny devices have elements ranging in size from 1 to 100 microns, about the thickness of a human hair. MEMS devices are generally divided into two categories: sensors and actuators. Sensor devices gather information from their surroundings, and actuators execute given commands, or act, generally through highly controlled movements. MEMS are made using the basic fabrication techniques and materials of microelectronics. Thin layers of materials are deposited onto a base and then are selectively etched away, leaving a microscopic three-dimensional structure. In this way, MEMS processes construct mechanical as well as electrical components. The electrical elements on the chip process data, while the mechanical elements act in response to that data. Hence, a complete system on a chip. Integrated circuitry provides the thinking part of the system, while the MEMS component complements this intelligence with active.
See, MEMS means here mainly sensors and actuators. That is, perception means sensors, it perceives. Action means controlling action. And IC part means the thinking part or decision taking part. Okay. See here, electrical part mainly process data, mechanical part mainly act on data. Anyhow, you need not bother so much things for examination, but have idea.
Intelligence with active perception and control functions. Known as MST, or Microsystems Technology, in Europe and Asia, the potential for MEMS technology is endless. MEMS devices are already used in an extensive range of products. They can be produced in large quantities with proven fabrication techniques. For example, crash sensors for airbag safety systems are actually MEMS devices that measure the force of an automobile crash and deploy an airbag if the force is great enough.
See, in an automobile, the MEMS accelerometer, which determines the acceleration, and if it is higher than a value, when an accident happens, there will be sudden uh, declaration. So, if it is more than a particular limit, the sensor will give indication to a device which will open or blow the air balloons. That is what is
Measure the force of an automobile
said here.
crash and deploy an airbag if the force.
So that the driver, the operator is saved from being hurt. So the sensor used is an MEMS sensor here. Even for earthquake sensing, many things.
This is great enough. Also, with the help of MEMS printheads, inkjet printers have developed from crude, slow, black and white.
See, in an inkjet printer, we need tiny bubbles of ink, very tiny. Say if it is 600 dpi, means 600 drops per inch. 1 inch is divided into 600 points or drops or bubbles. So very small nozzles. Nozzles will be very, very small. So the print head in an inkjet printer, that quality has been improved due to MEMS technology.
Devices to fast, flexible photographic quality images. And thanks to MEMS digital micro mirrors that control light, video projectors in offices around the world are now able to produce razor sharp, bright, colorful images. MEMS technology has become so widespread since its beginnings in the 1980s that it is estimated that there are now between 15 to 20 MEMS devices for every person living in North America.
Just imagine 15 to 20 MEMS devices per person in America. The population of America is around 30 crores. Per person, around 20 MEMS devices means Indian population around 120 crores of MEMS devices. Even our washing machine, mobile phones, computers, everything. See, when you tilt your mobile handset, it automatically selects whether you need portrait mode or okay, it will realize that due to the MEMS device there, whether you are holding it horizontally or vertically. Automatically, you can it adjusts itself according to your programming, means your settings.
There are two common examples of MEMS improving existing technology: the automotive crash sensor and the digital micro mirror device. A key element of modern automotive airbag systems is the MEMS crash sensor, known as a MEMS accelerometer. These sensors are more effective than earlier systems, meeting more stringent safety standards. The core of the MEMS accelerometer is a central mass that moves in response to a vehicle's acceleration. This inertial mass
See, very thin layer of a silicon is kept here. This is called as a cantilever, means fixed at one end and free to move at the other end. Depending upon the acceleration, the position of this layer or wafer will be changing. When there is no acceleration, means when the speed is constant, or when the when the car is at rest, this will be at its normal position. If the speed is increasing, this will move backward. If the speed is decreasing, means during applying braking, when you apply brake, this will move forward. So according to the position of this layer, we can determine the acceleration or vibration of the vehicle. These vibrations give us a lot of data for studying the characteristics of a machine.
is mounted on a hinge or spring that limits its movement and returns
Here there will be a hinge or spring where this layer or wafer is mounted.
it to a central position when at rest. Sensitive electrical sensors in the chip read the mass's movement and relay this data to a connected microprocessor. The microprocessor monitors the state of the accelerometer at rest and movement and returns.
See, for example, you have two plates here. Okay, and now this is a dielectric. Okay, now two plates, if you have across here between this or many, you will see that in the later, the movement will cause change in capacitance of the device. So change in capacity will determine the acceleration or force acting on the device, means on the car.
Turns it to a central position when at rest. Sensitive electrical sensors in the chip read the mass's movement and relay this data to a connected microprocessor. The micro
See, this is a MEMS device, okay, accelerometer, and that data is given to the microprocessor. Sometimes MEMS device comes separately, and this processor separately. Sometimes both will come as a single package. We have different types.
Processor monitors the state of the accelerometer at rest and in motion. In a collision, there is a sudden change in acceleration. When this change reaches an unsafe level, the airbags are deployed. The entire process takes only a fraction of a second and has saved millions of lives. MEMS technology allows crash sensors to be built from one or two simple chips. Earlier systems needed many electrical and mechanical components located throughout an automobile for measuring the same data.
Earlier vehicles needed many electrical and mechanical components to be mounted at different places and being connected by mechanical and electrical paths, mechanical and electrical elements to measure acceleration of a car, say. But now everything can be assembled in a very small sensor of, say, very small. The size will be set at the end of this video. It is around maximum, say, something around 3 millimeter size. Okay, we'll say that the a component is in micron level, but many components when used together for the whole device, it will be something around 3 millimeter and length. Say totally, the size will be 1000 millimeter cube. Okay, we'll see that it is given in the notes.
Reducing the number of components increases the accuracy and lowers the cost of these systems. The MEMS micromirror device, or DMD chip, is used in modern video projectors, home theater systems, and televisions. This chip uses microscopic moving mirrors to improve the image quality and overall reliability of these products. The micromirror device is, in its simplest form, a light switch made of millions of hinge-mounted mirrors. Each mirror measures about 1/5 the width of a human hair and corresponds to one dot or pixel in a projected image.
See, each dot is of 1/5 size of human hair. Each dot. So we have excellent resolution in a TV.
Mirrors are mounted on tiny hinges that enable them to tilt either toward the light source to reflect light or away from it to block the light. This creates a light or dark point on the projection surface. The length of time the mirror faces the light determines the brightness of each dot. In color systems, projectors can create over 16 million shades of color. These systems are producing such high-quality images that they are now being installed in movie theaters, replacing film projectors. MEMS technology will continue to quietly improve life as we move into the future. We may not be able to see the devices, but we will see its applications as they continue to affect our lives. Because MEMS is a flexible technology, it has the unique ability to improve current products, delivering new levels of performance and efficiency to both mass market and highly specialized applications. In the computer market, MEMS is revolutionizing mass data storage by miniaturizing components for disk drives, servers, and peripherals.
See, in hard disk drive, okay, when the size of each component is reduced, you can store more GB, more data in a given volume. So we can get higher storage devices.
Meeting the increasing needs for low-cost, high-capacity digital storage. In the consumer electronics market, acoustic MEMS chips are changing the way sound reaches our ears through cell phones, personal stereos, and hearing aids, providing less distortion and higher quality and clarity of sound. MEMS technology is meeting its potential for greater commercial use in several fields of technology. In addition, MEMS size and integration allow for whole new classes of products that would never have been possible with conventional approaches. In medicine, the advent of MEMS chips for drug delivery can benefit any patient who must follow a regimen for medication, as a single chip embedded in a patient can release the correct amount of drug over a given period of time. Also, MEMS sensors embedded in scalpels allow surgeons to measure the force and depth of their delicate incisions. The industrial market will see MEMS chips that detect gas leaks and other pathogen agents, keeping the workplace safe. MEMS technology is everywhere. It has become an inevitable part of the path to more effective and diverse products at the consumer level and beyond, and has already improved our quality of life. Products with MEMS devices perform better, respond faster, and are more reliable. They improve current products in ways that are not possible with traditional.
Diabetes, you can use an insulin pump used to deliver rapid-acting insulin to the body through a catheter ahead of time for continuous.
Are the computerized pump set delivers the insulin from the pump, then reconnect when finished. Cannula. An infusion set. The parts of the insulin pump delivery system that delivers rapid-acting insulin like no manage your insulin.
This is related to the previous video of insulin pump. Okay, parts are shown here.
Insulin pump can be a great tool to help you manage your insulin and blood sugar levels. An insulin pump is a small programmable insulin delivery system that delivers rapid-acting insulin like Novolog or Humalog 24 hours a day. This eliminates the need for multiple daily injections. The parts of the insulin pump are the computerized pump, which is programmed to meet your specific insulin requirements, a reservoir to hold the insulin, and an infusion set. The infusion set delivers the insulin from the pump through tubing and into the body through a small, thin plastic tube called a cannula. Once placed, you can easily disconnect the infusion set for activities like showering, then reconnect when finished. Every 2 to 3 days, new insulin is added to the pump, and the infusion set is changed. You can do this from the comfort of your own home when the change is needed. No hospitalization or help from a healthcare provider is required. To wear your insulin pump, you could simply put it in your pocket or clip it to any piece of your clothing. In addition to automatically delivering insulin 24 hours per day, you can give insulin to cover the food you eat or correct a high blood sugar by pushing the insulin pump buttons instead of injecting with a pen or syringe. With an insulin pump, you always have your insulin with you. Always having your insulin glucose levels every 5 minutes and sends your glucose levels. Some people also wear a continuous glucose monitor, or CGM, with their insulin pump.
See, you can also have feedback. Okay, glucose will be monitored by another device.
The CGM uses a sensor that measures your glucose levels every 5 minutes and sends those readings to the insulin pump. You can also receive.
Now, this will again recorrect and deliver the required amount of insulation. And also, you can also receive alerts.
Alerts if you go too high or too low, and then take action to get your glucose levels back to a safer range. Using an insulin pump can help you spend more time in a healthy blood glucose range, so you can spend more time enjoying life and less time managing your diabetes.
Making paper with the other hand. One hand while gently removing cannula and the layer of fat just below the skin surface. Clear window. Squeeze the sides of the insulin on the needle out. Press the adhesive tape firm and twist another quarter of the needle pointing down. Fill until you never fill your tube of insulin. Connect your back to the site. Now ready to resume your next. Fill the. Insert it into the cannula housing. other hand. Be careful not to touch the introducer needle when removing.
The same insulin pump is explained in detail in another video for you if you are interested.
Care provider's recommendation. Be sure to wash your hands and clean your insertion site. Please refer to your healthcare provider's recommendations when selecting an insertion site. First, remove the contents of your set. Hold the introducer needle with one hand while gently removing the front half of the adhesive backing paper with the other hand. Be careful not to touch the introducer needle when removing the adhesive backing paper. Now, carefully remove the needle guard by first twisting and then pulling. Prepare to insert by pinching the skin at your insertion site with one hand to lift the skin away from the muscle tissue. Now you can insert the cannula. Release the pinch, leaving the cannula and the layer of fat just below the skin surface. With the cannula inserted, secure the front piece of adhesive to your skin by pressing down on the adhesive tape. Next, remove the introducer needle. Place one finger in front of the clear window. Squeeze the sides of the introducer needle with the other hand and pull the introducer needle straight back. If you experience difficulty removing the needle, you may be pressing on the needle with your forefinger. Try straddling the needle with two fingers to secure the adhesive tape while you're pulling the needle out. Now, place a finger in front of the clear window to secure the cannula. Carefully lift up the back of the adhesive tape. Remove the remaining adhesive backing paper. Press the adhesive tape firmly to secure the infusion set. Next, attach the infusion set tubing to the tubing lock connector on the cartridge. Twist the tubing lock clockwise until finger tight, and then twist another quarter of a turn to ensure a secure connection. Remove the circular protective cap and fill your tubing according to the instructions in your user guide. When filling tubing, hold the connector needle pointing down. Fill until you see drops of insulin come out of the connector needle. Make sure there are no gaps of air in your tubing to reduce the possibility of interrupted insulin delivery. Never fill your tubing while your infusion set is connected to your body. Next, connect your filled tubing to your infusion set by holding the connector needle at the point where it connects with the tubing. Be sure you have the connector needle right side up to properly connect to the site. Insert it into the cannula housing. You should hear a click when it connects. Fill the cannula with 0.7 units. You are now ready to resume your pump and start delivering insulin. You've successfully completed the insertion. Always check your blood sugar 2 hours after inserting to make sure it's working properly. You may want to temporarily disconnect from your pump at times such as showering, swimming, and contact sports. To do this, always disconnect from your site by gently squeezing the side tabs and pulling the end of the tubing off the cannula housing while holding the tape with your other finger. Cover the connector needle with a circular protective cap and insert the disconnect cover into the cannula housing until you hear a click. Never disconnect at the tubing lock. To reconnect, remove the circular protective cap. With the needle pointing down, fill the tubing until you see insulin drip from the connector needle. Now, remove the cover from the cannula housing. Place your finger in front of the cannula housing and push the connector needle straight in until you hear a click. We hope you found this video helpful. If you still have questions,
See, it is very convenient to attach and remove the device from our body. Suppose say you are uh, going to swim. At that time, you will detach the device from your body. So the procedure is set there. Fine.